Alright, to honor the tradition of almost anything, part 1 of my Unreal Engine crash course is followed by part 2. So, welcome to part 2. In this episode we're gonna learn how to write our first custom code. We're gonna implement a dash for our character, so when we press left shift we can dash where the character is looking. We're also gonna learn a bunch about variables, events, how to add custom input for the dash, how to debug stuff if something's not working properly, how do we fix that. We're also gonna learn a bit about the concept of abstraction and why we might make things more complicated in the short term to manage complexity better in the long term, but we'll see about that when we get there. For now, let's open our first own blueprint. So go to third person, blueprints, and click BP underscore third person character. You see this editor will open up. There's a bunch of stuff all around us, on the right, on the left, on the top. Ignore that for now, don't get overwhelmed. For now, let's just drag the window like this so we can more easily switch between the map and the blueprint. That's what I like to do. And let's have a look around. So drag with hold down right mouse and drag. You can use the scroll wheel to zoom in and out, and you can use left mouse to select stuff, like in the viewport. Okay, so far so good. These are what we call nodes. So basically how blueprints work is that you put a bunch of nodes behind each other. Let's look at this example. So it starts here in this event, then it goes to this node via this execution line, then it goes to this one, and there's two of them here, and if this is valid, whatever this is, not important right now, then it goes to this. And that's basically how blueprints work. So you put a bunch of nodes behind each other, and sometimes you can decide whether you want to keep going or not based on some condition, whatever you want that to be. So blueprints are one of the two ways to create code in Unreal. The other would be C++, but that's more complicated. So we're gonna exclusively use blueprints in this course. Yeah, let's get right into it and create our dash. So, to add an input, let's go back to the content browser here, browse to input, actions, and you will see move, look, and jump, the three actions that are also present in here. They are defined as assets here. Let's right-click to create our very own asset. So there's a bunch of stuff you can create. Head over to input, input action, and click that. We can give it a name. I suggest you name it like these. So IA underscore for input action underscore, and then dash, because that's the name of our input action. Make sure you save. It's very important to save often. Otherwise you might lose progress, and that's no good. The reason we named these IA underscore is just, it's great for filtering stuff, so if you just quickly want to find all assets that are input actions, then you can just search for IA underscore and you get them listed. Very convenient. You can open this up. It's not really that important. Nothing in here will need to be changed for now. Before we can use it in here, we need to do one more thing. Go back to input. Open up this other asset, the input mapping context, and in here expand this. You will see the free action listed in here. We will need to add our own. So click plus, then this drop down, and add dash. If you look at the others, expand that, you can see we have the keys defined here. So jump can be activated by the space bar, but also by the gamepad face button bottom, and by touch apparently. We're just gonna add left shift, so search for that and add that. Okay, great. Now save that, and now we can use this. So if we do dash, you can alternatively just search for dash. Yeah, the way you add nodes is you right-click, and most of the time you want to search for stuff, because as you can see, there's a whole lot of stuff down here. So just type in dash, Click it, and you can see something very similar just popped up for a dash input. Great! So, the way you can add nodes from here on is to just click and drag, and when you let go, you can see this window pops up once again. We're gonna add a print string, which basically just prints a little message in our viewport when we play the game to see that it's working. We can set a custom message like dash. To make sure that our changes are saved and then they show up when they play the game, we need to compile. As it says here, when it's not compiled to the latest version, it shows this little question mark, so make sure you compile. Now it's a check. And also make sure to save, because, yeah, once again, saving is important. Head back, press play, and once we press shift, you can see on the left there's our print string function. We've just written some code. It doesn't do what we want it to do for now, but that is totally okay. Okay, I'd like to just take a moment and have you look at this. If you think back, we added something called an input action, then we added it to an input mapping context, and then we wrote some cool code. So you might be wondering, why make it so complicated? Why not just say when this button is pressed, then do something, in our case left shift, then dash. And the reason for that is we could technically do that, that would work, but I want to show you a more proper way of doing input. And the reason is, the reason why we have these two things, the input action and the input mapping context, they provide us with several benefits that will help us manage complexity better down the road. So that's a bit complex, but let me explain some benefits of them. So, let's say we put an input action first, between the keys and the code. Now we have the benefit of allowing multiple keys from multiple different devices even to execute this one action. So you saw this with the jump. You can use spacebar, but you could also use a gamepad button and even touch. This is one convenience. Plus something else, you can also, this also supports remapping keys, because most modern games do allow you to rebind keys to your heart's desire. We're not going to do that, but this is another thing that the input action provides us with out of the box. So it's something we don't have to program ourselves, or at least not that much if we use these. And the input mapping context, there's a reason why we might want to do that. For our game, a single one is enough, but you can have multiple ones. And this is kind of the inverse, like if a key under different contexts does different things. So a really good example from the official Unreal documentation that I found is in Fortnite. The control button does at least 3 different things in 3 different contexts. So when the player is not crouched, the control causes the player to crouch, and thus we want to execute the crouch code. Let's say the player is crouched, then the control button uncrouches the player, and thus we want to trigger the uncrouch code. And if the player is sprinting, then control actually slides, so we have slide code. And basically, if we have 3 different mapping contexts with these input actions bound to different code, then this helps us manage complexity better. Because otherwise we just have one big bundle of code and it would get very messy having to do all of that in code. I know this is all a bit abstract, but there's such a thing called technical debt. Basically, I'm gonna put a really nice comic on screen. In the beginning you might say, okay, we're gonna do the simplest thing, like this, and yeah, it's quicker than if you were to add an input action and maybe even a new input mapping context. But in the long term, the very simple solutions often slow you down, so that's why you abstract. So that's why you say, we put an input action between that, and then we're also going to put an input mapping context between that, because it helps you manage complexity better in the long term. And in this case, it also comes with some nice extra features like rebinding keys and mapping multiple keys to one action. So, yeah, that's just something I wanted to mention. Abstraction, very important topic. You will most definitely run into technical debt in your own projects. It will slow you down, but I think that's the best way to learn, and to learn why abstractions are so important and the easiest solutions aren't always the best. So now you know why I will sometimes jump through hoops, it seems, to reach a goal that could also be reached in a much easier way. Because it's just better in the long term, and I want to teach you more proper ways. Alright, back to the editor. So now we actually want to implement the dash. Right now we have this print string, but that's not what we want. So you can click or click and drag to select it, and then press delete to remove it. Now we actually want to add the code that, well, makes our character dash. I'd like you to try and find a method, right-click, and then search for something that might produce the desired result. And I'm gonna give you a tip. Think about how we can launch the character, and I chose that wording very specifically. See if you can't find a function that looks like it might do the right thing. Oh yeah, you can pause the video, give that a go, and see if you can figure something out. Whether or not you were successful, the function we're looking for is launch character. With Unreal there are multiple ways to do this, but I found this one to be the easiest to use and understand. We're going to do that. We're going to plug it in here so it actually executes. Now this function asks us for a target. So basically these are the inputs of the function. The function needs several values to, well, do stuff that we wanted to do. We don't need to put anything in here, but we need to put something in here. So this is a vector, which you hopefully know from school. And basically it's just a direction. So in which direction do we want to launch the character? Currently it's all set to 0, so we're not launching the character anywhere. But what we want to do is basically launch the character in the direction that they're looking. And you could also launch the character in the direction that the camera is looking, because, you know, with third person, now the camera is looking in the opposite direction of the character. This is really up to choice. I'm just going to show you how to do it with the character, but, like, with the direction the character is looking in, but that's really personal preference, and that's more of a game design issue than a programming issue. There is a really simple function to basically get the direction in which the character is facing, and that is called a forward vector. So there are multiple functions that are called something with forward vector. We're going to use the function getActorForwardVector. If we plug that in now, you can see they're compatible. If we tried this, you would see that the type doesn't match, because the type here is vector, as you can see. This type is also vector, but this type is Boolean. So different values can have different types, and they need to match. Click compile, and if we do this, then you can see that nothing is really happening. We might be, we're moving forward a little bit, but it's not really noticeable. What we want to do is, we're getting this vector, but it's really short. Alright, so currently we have our character here. The character is looking in a certain direction, and we are getting the forward vector. So, this little arrow. But it's really short, so our character isn't launched a lot. What we want to do is multiply this vector by a rather large number so that our character is launched forwards more. So, yeah, let's see how we can do that. In the editor, drag out from this, just punch in a star, and you can see we get a multiply operation. This is just standard multiplication. To make sure the result of the multiply is actually applied as a launch velocity, you need to drag it in. And now we can multiply this vector by these values. What we can also actually do is type in make literal float. Drag that in, and this is an exception. Even though this is a float and this is a vector, Unreal is actually smart enough to match these two, and the multiplication function now adjusts to include a float. So let's type in something like 1000 to make it much more noticeable. Compile, save, and play. And you can see our character is launched quite a lot. Yeah, that's maybe a bit too much, but maybe not even. I'm gonna show you something. You don't have to do this, but I'm just gonna quickly add a print string. And you can see that hello is being printed multiple times. So meaning, not only is this function run multiple times, but also this function. So the character is launched multiple times, and all this velocity, basically the direction the character is moving in, adds up. So the character moves really quickly, because they're launched like 10 times with 1000 velocity, and that all adds up. What we can do is just say we want to override it instead of adding to it. So instead of it getting more and more, it just gets, well, overridden, and now it doesn't really matter if the character is launched like 12 times. Alright, and as you can see, our dash is much more manageable, and it's even a bit of fun to use, which is great. So, as you can see, this works just fine in the air, but we can still dash as many times as we want in the air. It's not really that noticeable, but on the ground, if we do that, then we might get this very strange animation, and yeah, it's just a bit strange. So, what we can do is actually disallow the character from dashing on the ground. Or we could say the character should only be allowed to dash once in the air. So multiple things we could do to improve this mechanic. I'm gonna show you a way to limit the character from dashing in the air multiple times. And the reason for this is so that I can introduce variables to you, which are pretty much essential. To add a variable, which is basically just a value with a custom name that we can define, access, and then change, and keep track of, we're going to name our first variable can_dash. The question mark, it's kind of a convention as well. Compile and save after you add a variable. And this variable will basically decide if we can dash. So to only check if we can currently dash, drag it in, and get it. So we're getting the value of this variable, whatever it currently is, then hold down B and click to create a branch. So as you can see, this is red, and it's both Boolean, so you can plug it in. To change the flow, to go through this branch, click and drag. And we only want to dash when we can actually dash, so when this is true. And this is another way we can basically limit the execution flow. So when this variable is false, nothing will happen because nothing is plugged in here. Okay, so this variable is currently set to false by default. We're going to set it to true. If we hit compile, you will see you can still dash just fine. Nothing has really changed. To change this variable, click and drag it in. And you can hold Alt to automatically set it. So now we're going to set the value. First we get the value to see what it is, and now we change the value. And we just say can_dash is set to false by basically leaving this unchecked. Okay, as you can see, this is also a Boolean, and we can also check and uncheck it just like this. We just made our own, and here these are values that are already predefined. Very nice. Okay. Now when we dash, you can see we can only dash once, and afterwards, if you press shift, we can no longer dash. So we need a way to reset the variable to true, so we can dash once in the air, and then when we hit the ground, our dash is basically reset. To do that, we're gonna add our own event. As you can see up here, there's an event, and events are basically just things that happen during certain times, and you can say when this event on landed has happened, so when the player lands on the ground, we want to reset the dash. So click and drag, Alt once again, connect these up, and this time set it to true. Compile, save, play. And as you can see, we can now dash again once we've landed. Yeah, it's reset. Very nice. Okay. So this is how you use a basic Boolean variable. Boolean basically just means it can be true or false, and this is a is a very essential data type, so definitely get familiar with booleans, at least to a certain degree. We could do more. We could limit the strange dashing on the ground. We could obviously fine-tune our dash so that it feels nicer, but I just wanted to teach you the very basics of programming and not how to make a feature like fully complete, feel very nice. That's the whole art in and of itself. So we're just learning the basics for now. For now, we can live with a little bit of weirdness in our games. So last but not least, I also want to introduce you to the concept of state. So here we have our character, and our character can have multiple variables. Currently, character only has one, can dash, with 2 possible values, but we can have as many variables as we need or as the heart desires. And all of these variables basically make up the character's state. So variables plus the functions that manipulate them are pretty much, you know, how a lot of programming works. You have a bunch of values, and then you can change them, and you can only change them under certain conditions and whatnot. You can get really fancy with this. You can have functions called other functions, which in turn call other functions that manipulate variables. Yeah, it can get very complicated, but for now, just know we have variables, which are values with a nice name and a certain type. And we have functions which can call other functions, and these can also change variables. Alright, we have successfully added a little dash to our game. We've learned about inputs, we've learned about blueprints, we learned how to write our own code, to test our own code, we learned about variables, how to add them, how to change their values, how to read which value they are. We learned a bit about state, what that is. And yeah, now we know the basics of programming. So once again, this was a lot in one video. Don't worry if you didn't understand everything. You can rewatch it as many times if you want. And if there are any things left that are unclear to you, then you can ask them in the comments, and hopefully I can get around to answering your question. You can also join my Discord, link in the description, if you have any further questions or if you just like to hang out with me. And yeah, I will see you in part 3, where we will add our own custom actor. We will add coins, which the player can collect, and we will learn how to keep track of how many coins the player has collected. So I hope you're looking forward to that, and see you then, and Creator out.